Okay, the early bird catches the worm, and I've got worms, I guess. Let me just check. Yes, excellent connection, says the streaming software. Oh, there's no. Are we not actually streaming? Yeah. Okay. I need my key. Hello. It is Sunday morning. We are. So I'm a bit early. Not that. Not that it matters because I forgot. I had committed. Like I'm doing Sunday 2-hour streams, 10 to 12. Except I'd forgotten to put. I put them in my diary, but I forgotten to put them in YouTube's diary until like literally 10 minutes ago. Hey, the skit and Yeet. They can see me. All right. Thank you for the little heart. What are we doing today? Skitty vlogs. Do you have a preference? Because I got some good stuff lined up. Let me just cut through that. All right, so this is the 2018 one. It has a Dijkstra, which is very exciting. No, it's nothing to worry about, but like it's a pretty cool one to do. To be fair, that's legit and worth doing if because like this, it will have a very characteristic look on the EAD. So I actually have not seen the EAD this year, but yeah, I was told by someone on the stream that might be that. I also have some section B problems like run length encoding. Yeah, that's not a bad one, right? Write the program compression, suitable prompt, include the text compress, output the compressed text. Or we have, and that's a prime computation problem. Yeah, so that's the plan. I'm only to be doing section A and B. Sorry, there's like a 60-second lag or something with the comments. Yeah, so the question is which one? Or I feel like maybe, I got down the list of the tasks and we're now looking at stuff that's really good to learn the code, but like arguably less realistic when it comes to the exam. So something like maybe practicing a small section D, sorry, like, accept carets for exponentiation, or even quit the game. There was kind of like definitely an early one in Wikibooks and maybe even in ZigZag. Now I'm going to warm up with, yeah, let me warm up with like a straightforward, what's going on. I don't need that just yet. Well, this is if you want to do Dijkstra. This one. Yeah, okay, coding task. Was there something at the top? I think they've got exponents further down the... Oh, no, there's 15 where you encode the whole thing. We could even do it with an OOP, but again, do what this says. The values with 2 points. Nah, don't like this one. We've done this one. Difficulty levels, no, terrible. Quitting the game, yeah, that's kind of like an easy one. Is that it? No, not target by numbers allowed. Divide by 0. Yeah, the error messages, that could be like in 6-8. I don't know what the first one is. Let's do, yeah, exponents. I think they've got caret. Indices? Is it, would they have? Right, yeah, okay. Okay, in French, an index is the one you put as a subscript, and an exponent is what you put as a superscript, which is so very weird to kind of, hear powers essentially described as indices. All right, Z14, let's do this. Original, copy it, paste it, rename it to Z14.py. Hide this. I'm going to put this to the side so we have it. To the side of it. Section A and C. Where we get some kind of, yeah, the ZigZag does some stuff, but section A, I can do a Dijkstra. Let me just do this one, and then I'll move on to the Dijkstra. Okay, so we want convert to RPN to the correct precedence. So it's BODMAS, right? Meaning it's before everything else, because we don't have B, but we have O. And evaluate RPN, check user input invalid. Should we do them in order? Yeah, in order, right? Convert to RPN is where the magic happens. So if plus and minus I've got 2 and this and that I've got 4, we want caret, the operation for above the 6, the operation for exponentiation to be I mean 8, I guess, or 6, whatever, like at least 5, right? Because it needs to be the one that gets the higher one. That's how we need to do that. Everyone's happy. Let's go to check user. Well, let's evaluate RPN. So here we need to add a caret, and then in there we're going to put an elif. So input RPN at index 0, so that's the kind of operators we're reading, and if that's equal to a caret, we are going to say that result to num1, and in Python it's star star, right? Pretty sure. Okay, 2 to the power of 3, 8, right? 2 stars. If I space them, it doesn't work, right? So it's like 2 consecutive stars. Yeah, section A and C, right? So I'm just going to finish this one so we get it, but then I'll do section A in the shape of the Dijkstra trace. So here it's num1 to the power of num2. We've done evaluate. Now the one thing we need to do is this one, check if user input is valid. So at the moment, those are the operators, right? It needs to be an operand and an operator, and that might be any number of times, and the final operator. So in here, we'll just want, they're all double escape. So double escape and caret. Ooh, sorry, I'm on a PC keyboard, but Mac mappings. Save this. Just run it real quick, just to check. We like the training game. Not sure if that helps me much though. 3 to the power 2, yeah, 3 power 2. Boom, cleared the 9, got a point, right? This is like, you know, a fairly, yeah, that could be a 5-6 marks. So this is, or select for compare is the original, and I know I've done some of those before, but you know, like it's the dictatorship of novelty on producing content. Compare is selected, that's our diff. Let's put this guy back here. So we need to accept it as, so in convert to RPN, we just set its precedence. And then in evaluate RPN, we accept it as a list of operators and we handle it with the power. And then finally, just when we validate the expression, we need to accept it as an additional possible operator. This was, yeah, this is literally this is just before the stream starts. That was kind of like in 5 minutes. Okay, so let's do some section A. I have readied the thing here. Okay, that's right. So that's the graph. I can get that smaller, but right. Time it takes to travel between 6 locations in a warehouse. 6 locations, there are nodes 1 to 6. There's an age, means when there's no age, it's not possible to travel. When there is an age, the graph level is an age, which I mean minutes. It takes them from 2 locations. Yeah, okay. So this is a weighted but undirected graph. This adjacency matrix, so for that diagonal column is black because it's symmetrical. You know, you bear the same weight going in as you go back out. It will have a symmetry across this angle. So right, like 1, 2, it's 2. Right, because like this is not, we're not interested. Like this is 2 marks. Forget the adjacency matrix. In which circumstance it would be more appropriate to use an adjacency list instead of an adjacency matrix? That's something you kind of need to know. If there are few connections, it makes more sense to have an adjacency list, certainly in terms of storage space. Why is it not a tree? Is get a cycle, like a pool of cycles, 3 of them at least. Actually, maybe like 4 and then 5 if you could, yeah, plenty of cycles all around, so it's not a tree. A weighted graph is something where there's a weight, there's a numerical value. What is going on there? Chat. Yeah, so that's a weighted graph and a numerical graph. All right, here we are. Right, the pseudocode for a version of Dijkstra's algorithm used to graph in figure 1. Q is a priority queue, which, based on the values in array D, that's distance. The reordering of Q is performed automatically when a value in D is changed. And in fact, I think they do this for you, so you don't mess it up, although it does feel like that this will stay in the order they came in. But like this has come not only with the top, but a lot of the side shaded. I don't know I don't know, like I've not seen the AD, so I don't know what the table looks like for this year. I was told by one of you young folks about this. 7 mark. Okay. So I'm gonna need like to split up. Oh, I didn't want to do that. I don't know what I've done. This is... Oh yeah, no, okay, split up. Yeah, no, fair enough. Just like, that's not what I want to do. I want to have... Maybe I'll... Can I... Yes, okay, sweet. No, still no. I just have 2 copies of it open, so I can have the graph and the algorithm. All right, we'll have just the algorithm to start with. No, because we need both. Bloody hell. I'm feeling completely deflated. Mars Phantom, like if you want to, like I need to look at the AD to be able to tell you. Tracing the Turing machine, that would be devious, but why not? It's just possible, I suppose. I don't know of any that could have, I don't know of any like Turing machine trace in the past, but that might mean that this is the year it needs to come up. Right, so I've made the trace thing here. I just want to get stuff a little bit organized. That's my trace. That's my algorithm. Copy it here and then move it. Can I like split them in quarters? Yes, here. And a copy of this one. No, it doesn't want to do that. Fair enough. Well, we'll have to scroll back and forth like some kind of caveman. Annoying. I think that we already have the weights in the adjacency matrix. So Q is the empty Q, and then it gets initialized for C1 is the iterator in terms of like the nodes number. D is going to be the distance as far as I can make out. P is visited, or the path. Add C1 to Q, that's what we've done, right? Because like we... Oh wait, no. So like we just... This is the initialization, right? This will kind of... The Q starts actually empty, and then we set 20 in all of the Ds, and -1 in all of the Ps, and then we populate the Q. And 4, right. D1 equals 0, they've done this. While Q is not empty, it's not empty. U is the next node for thing, they got this. We move U from Q, we've done this. That's kind of the point of a Q, right? Because that should be, if it's a Q, those things should be the same instruction, but we get it. Then for each V in Q, so we start with V being 2, where, okay, AM, the adjacency matrix, so the weight between U and V. So U is the one we're checking from, and V is like the neighbors we're evaluating against, right? For each of those. A becomes equal to the distance to U, so to U. Oh, because these are going to be numbers, right? So D1, was 0. Yeah, because it's on it here. Plus the weight. Right. So here we kind of calculate A is going to have like the distance, this is basically the distance to the node we are, and then plus the distance from the graph. And then if that's slower than what we already have, we replace it, right? Because if you come in a shorter path, you do it. So the graph is this, so between 1 and 2, it's 2. So this is going to be 0 plus 2, that's, so 0 plus 2 is 2 in A, right? So like the distance to U, the distance to the first node, plus the weight of the arc between this and that. And then if A is smaller than the distance to V, which it is, then the distance to V becomes equals to A, so that's the distance, and P the path, which, do I have a scrolly, what? All right, and P's, the P is for path, becomes equal to U, right? So so U is the node from which we are from, so like this is the previous. So we got a distance of 2 coming from node 2, coming from node 1. That's the NDEF when here. We kind of now loop again for each V and Q, meaning that they have given you this actually, right? So now we're on that line. So it's going to go all the way here and a new row. Okay, trace table like freak everyone out. The rule generally, I mean, don't just assume if the value doesn't change, you don't need to kind of populate it. And I think only take a new row when the value change. What's good about this, if it's the one, I don't know if the one you have in the EAD, but at least this one guides you. So it clearly states what is changing every time you kind of do a new row. So we've done this, we'll node 3. This is still node 1. So from 1 to 3, at the moment we've got a distance to, so the distance to node 2 was 2. And 2 plus 2 to 3 is 1, right? So 2, that's 3. That's continued from, no, because it's from 1, sorry, that's 5. This is we're going to find out. So at the moment that's going to go in 5, because from node 1 it's a 5. It's more than 20, so it's a 5. And in here we put, ooh, I messed something up here. Is it P? No, it's P2, right? Because, okay, the code, the algorithm is of V. So this V was the neighbor voisin we were looking at. Yes, that should be here. And so now we have, yeah, again, we've done this here with 5. Cool. Happy, add a row. It's time to do kind of, yeah, we're gonna have a bunch there. So let's kind of do them now. All right, 2, 3, 4, 6, and then we're back to 2, 3, and 3, 4, 5, 6. 6. I could have prepared that before. I could have sorted this out before starting, but hey. 5. Yeah, because messing this up will be. This is awkward. It says 3, 6, 6, 6. 6, 5, and then 6, but there's nothing there. So yeah, I mean, empty string, empty list, and there's nothing there as well. All right, so we're here. Now we are still from 1 to 4. There is a route to 4. It costs us 3, so the cost of that plus 3, that's just 3. It's smaller than 20, so we kind of populate it here. And the previous to get to 4, sorry, was 1. Can I? I think in particular, so it's not everything. Q might need to get a bit bigger. Okay, let's have them all. No, have them all like 2 characters wide. I can't find the right. It's like pixel hunting. I've seen it change. I move fast. Okay, let's make that small. But then the Q needs to be bigger. Bigger even. Cool. All right, that's looking more like the thing we want. Except I feel like I've broken this as well, which is not great. So just take. Shit's happened. Oh no. Let's just undo the. Where all that stuff from? Okay, new one. It's okay. We don't need even the rows. I'm very sorry. We're gonna start it again. No, it's well, yeah, okay. That's important here to get the 0 here. That was the thing that has changed, right? So new row. We're still in 1. That doesn't change. From 3 we found 5. So 5 goes into D3, and the previous for 3 is still node 1. Then for 4, I think it was like 3. So 0 plus 3 is 3. That's still smaller than 20. It goes here, and the previous for 4 is. Am I missing a? Oh, shit. Did just right. I was missing a not here. Edit header cell. Yeah, that's the one I want to edit as a P5. Cool. Okay, and the previous is 1. Right. Next row, please. Okay. traces here. No, so the next node we have available from 1 is 6. So even 1, 2, 3, and then 6. So 6 is here. Still, the distance to 1 is 0, plus going there, that's an 8, which is smaller than 20, so we got 8 in here, and we have a P6 previous node for 6 is also 1. So this tells us we got that coming from this one. Right, let's kind of now get some more interesting stuff where we might find intermediary. We'll finish with this. Now our U node, the one we're looking at, is 2, meaning here I've got like 3 to 6. The next node we're looking at is 3. Now, this is where we are here. This is our selected node. Look at the first connection. It's 3. We find that shortest known path to 2 plus the cost of going from 2 to 3 is 3, which happens to be lower than the shortest path we had for 3, which was here. So that then this goes here, and then in here we're going to put the 2, because now we'd have to come via node 2 to figure it out. So that's why if you want to go, all right, so how do I get that to that free path to node 3? You think, oh, you need to come from node 2, and then you look at node 2. There's a 2 path from node 1, and then from node 1 you're here. So this is how you would kind of, not only the shortest path, not only the total length of the shortest path, but the actual path to it. Next row, please. So there's another connection from 2, but that's 1, so I think they skip it because we... No, that should... No, sorry, in queue, right? They have to be in the queue. So if we visited it, they've popped out of the queue, they're not considered at thing because we've done, it's a symmetrical graph, right? And we know the path from the other way around. So that's why here, when we move on this way here, we don't look at this path because we've already covered it going from 1 to 2. So the next row in there is straight up with 3 as U. So this now contains 4, 5, 6. And the only neighbors we're looking at for you is scrolly, scrolly, scrolly. 3, we've done, those 2 routes we found, and then there's 6 here. So 6. Now the A for this, right? We know we can get to 3 in 3, and then on top of that, that's 7. 7 is smaller than 8, so it goes in here, and we now know that from 6 you want to come from 3, and from 3 you want to come from 2, and from 2 you want to come from 1. There's then another row because we need to kind of do the 4 and the 5s as well, right? So there's a 4, the queue not only contains 5 and 6, and the next one we're looking at is 5 because, so from 4 we've already done this one, so it's 5. We're looking at the connection to 5 and 5 as a neighbor. Our shortest path to 4 currently was 3 coming from 1, yeah, and so now that path to 5 will be 4. This is the first path we're finding for 5. So that's when it's smaller than 20, and we know that to go to 5 with the shortest path, you need to come from 4, and to go to 4, you need to come from 1. Yeah. The next row, 5. There's only 6 left. 5 here. There's only 6 left in the queue. From 5, we are looking at 5 to 6, right? Because it's the only one that's remaining. So currently, our shortest path to 5 is 4. So going to 6. So 4 plus the 5 of the thing, that's a 9. The current shortest path we have for this is 7, so we don't change anything in the D and P arrays. And then in 6, I don't know what they really want here, but yeah, I guess you could have a row where there's like 6, and let's see what the conditions of ending in here. The queue is not empty. We get the next node from queue, but there's no V's in the queue left. So this skips all of that, and then we output the distance to 6, which is here, which was 7, right? There's no output, there's no output column there, right? The output of the algorithm in figure 2 represent the output, represent the shortest path from, remember, this was from node 1, right? It's kind of implicit because it's the first one and so on, but that would work anyway, right? If you that's just the starting one is the one where we're already at, that's our departure point, because the route to there takes 0 minutes or kilometers or however you're counting, right? So the output represents the shortest path through that weighted graph, from 1 to 6, and that involves as we've established. So P6 just literally coming straight from 1. Yeah, because we find out that it's not shorter going via 5 and 4. The contents in P were changed by the algorithm. What is the purpose of the array P? To know which is the previous node of the shortest path to access. Yeah, I don't know, I would word it correctly in 2 marks, right? But we get that it's kind of, in order to get that score, that cost, you need to be coming from this one, and then from this, implicitly from this one, you can reconstruct the full path. There might be one mark to, yeah, I think, well, we'll have to mark him in a second. Oh, that, and we're done. Okay. Maybe have a, yeah, let's have a look at the mark scheme, I guess, for this. That was the 2018 maths and physics and maths and maths tutor. No, I don't want the computer science revision. I want the past papers in computer science. AQA paper 1. A level. None of that AS. None of that weak source. And then the 2018 QP, the 2018 mark scheme. I haven't even opened yet. This is going to come with the weird advertising from Physics and Maths Tutor that offers me some, physics, obviously. We're super interested in physics, obviously. Yeah. All right, like give us to the good stuff, design and, okay, so this was question 3. Is the old Dijkstra? Yes, that's the adjacency, whatever, we've done that. 584. No, okay, no, I'm not, yeah, I got this. 253.83749, yeah, I got that. 3, yeah, that looks like the table, right? So it's not, you just remember the hardest part of those is just like not panicking, because each of the operations you need to follow is literally written in the algorithm above, and it's just kind of like not losing track of what you're doing and trusting yourself, right, that like you can actually do this. But because they stack a tiny, large amount of kind of ultimate small operation, which is the point of computers, if you think about it for a second, right? So here we're asking the computer scientist the most dumbest thing ever, which is to act as the computer. But it's important, this concept of the notional machine at which you program, you have almost a mental model of the computer in your mind, so that you know like what instructions will make it behave. And sometimes more explicitly, this will be done with a trace table. Okay, that was Dijkstra, and that was like 15 minutes, right? So, gosh, I was hoping there was more to this, but I might make a video. I wouldn't do it on a live stream, but there's a really cool package for Python called Network X to visualize graph, and that's actually I want it, but anyway, that's kind of for non-A level stuff. Well, it's kind of A-level stuff, but like not like revision. It's like 2 weeks before the thing. Let's do the thing. Okay, so next up, I think section B, right? So section B, I've selected 2 of them. This is from I think 2017 and 2018. This one is from 2017, I think. And let's do run length encoding. I like that. I'm digging this. New file. Sec b, well, le.py. Poof. No, I don't. I thought that disable all of the open chat. Oh, don't show this again. Thank you. Okay. Which numbers? So series, asking you to know the number, should repeat it. Okay, right. So section B's are kind of tricky because you need to nail this. And I've not cut the thing, but like they advise you not to spend more than, and they advise you not to spend more than 20 minutes on those. So let's just like do the thing. Okay. So ask bigger. Yeah. Ask the user even bigger, maybe. Yeah. Ask the user for a number. Test if it is prime, and then ask again. Okay, so let's do the kind of skeleton of And well, the number, no. Okay, so let's call it not input because it's a reserved word, right? Like, but string. Okay. Let's not do int, it's input, obviously. See, I'm getting flustered. Okay, 2 minutes. I've only spent 2 minutes. Ah, nightmare. Right, this is like mimicking the exact exam conditions. Right, user input, and while the user input is not equal to the empty string, it's going to ask it for the first number, but that's fine. Like it's going to, you know, that's I like this architecture. We don't need to import anything. We're just going to add the top, like some kind of animals. All right, so while the user input is not that, we're going to say that the number is equal to an int of the user input. They tell you, like, you can safely assume, you may assume that each number used is an integer. Well, if num is 1 or less, right? Print not greater than 1. Okay. Else. So you notice what I'm doing, right? Just kind of like separate the problem, right? Something like around the logic of the code to say it should print this, it should print that. So else and if, immediately I feel like we can probably simplify this, and then else print. And then what you can do, right? What you can do is like, you know, we're going to diff to def and is prime. But if you want to have the test, you could say if num is equal to 5, return true. And if num, because you know you're testing it on 8, right? Return false. Okay, I believe that this will actually pass the test. It should be num smaller than 1. Yeah, you're right. Thank you. Yeah, obviously. This could have is prime. We've defined. I think it might be annoyed because we kind of want to define it before. And if you want to do the thing with if main whatever, I would have to copy it somewhere else. Like if you want to, you know, kind of run the main, if there's not been whatever, it's kind of they're not asking you to engineer it to that degree. Okay, so return quit. That's already proven that. But let's do it in order, right? So number 1, not Q. Okay. Where's the run button? Okay. Right. So first we need one. Choosing another number, well, I feel like, should repeat if they say that they do. So it's going to be, you want to separate input to say another number, yes, no, and do another thing. Oh, come on, this is ridiculous. Right, so 1. Oh, yes, I've made a mistake here, haven't I? Yeah, I was clever with my while to ask again and stuff. All right, what's my problem here is that I need, of course, at the end of this to reset. Oh, no, of course, at the end of this, I need to actually ask again, right? So that it gives it a new value and then it will leave, like, you know, quit if I enter nothing and then go back and use my number here. Okay, this was the slightly specious to say, hello, MCX edit Z. Slightly specious just to show you that you can pass the test cases saying 1, 5 is prime, 8 is not prime, 54 is not a prime, 3 is not a prime, right? It's kind of like else. I should have put an elif, you know, elif 8, but that's the spec. But that's not how you detect primeness, right? I'm wasting, well, only 5 minutes, I'm good. Okay, so what you want to detect primality, primeness. The fact that a number is prime, it means it's divisible only by itself and 1. And they are magic. I just saw something on Mastodon, which is like the maths people on Mastodon, and someone had a picture of Leonard Euler, because it's pronounced Euler, like working out the kind of distributions of prime on a sheet of graph paper and trying to figure out some rules, and I think it did in the end. Okay, so let's say we are going to first seed. Well, we actually need nothing because it needs to work with 2 or 5 or whatever. But like, all right, primes isn't going nothing. So we want to for I in range num. I mean, normally that should be kind of like, it should be square root of num, but like to get square root, you'd have to import maps, so whatever, right? For I in range num, so it's going to go to 0 to num minus 1. So I think we can probably do like 1 num, so it kind of does it a bit better. Oh no, sorry, I'm kind of only. I was thinking we would work out the primes and populate them, and so like, you know, by 5 we knew that figure 2 and 3 are primes, so we knew what to try to divide by. But we can just like literally brute force the thing and say, right, for integer range num, if num, so finding something divisible means the remainder of the division is 0. I swear, this is, I thought I disabled the dumb, I'd run out of like requests to the AI. So if the remainder of division by I is equal to 0, then we can return false immediately, right? And then here we return true. Now this might take a while, but it will correctly identify primes. Well, I mean, okay, I thank you, Zahid. It means a lot to me. I will say this in defense of the teachers that don't do this. Yeah, no, Mars Phantom is right, but I think like there's a computationally more clever way of doing it, because you don't need to test for everything. You just need to test for the primes that are lower than what you. But that means discovering all primes. All right, let's test it. Well, let's test something fun, right? So 31 is a prime, right? 31 is not prime. Okay, 27 is not prime. 29 is prime. Did I not? Sorry. Okay, so that doesn't work. That's good. Oh, sorry. So it can't be 1. It needs to be 2, obviously, right? Yeah. So 1, 2 is prime. 3 is prime. 4 is not prime. 5 is prime. 6, 7, 8, 9, 11 is prime. 13 is prime. 17 is prime. But then this long number. Okay, no, that was quite quickly. Okay, I just didn't correct it. Yeah. Yeah, okay, fine. I want to do the clever thing where you kind of discover the primes and add them to a list so you can only test primes and so on. But we only, yeah, that's the thing we want to do. Okay, so if you want to be like do it what they wanted is okay. Christ. Let's put this here, and you're not gonna return to quit, right? It's just gonna be this, and then here I'm gonna say again. So while again. So it's gonna ask again. That's for the number that do its thing, do its magic thing, and then we need to say ask if they want to run the program to repeat if they say they do. So like, you know, okay, so input into variable, but like not call it, don't call it again. Well, let me again. You know what? I'm gonna go whilst again equal y. And actually set it to y and do again equal input And this input in uppercase. So that way, well, even if I type a lowercase y, well, so this is, I think, what they wanted specifically to do. So first set number, which is going to be 42, which isn't prime. Again, yes. And so number 7, and then no. And then, yeah, so that's your section. Well, that was 10 minutes. I mean, come on, like, just give me something. Give something with a bit of meat. Right, let's do the other one then. That's not, oh, sorry, I wanted to do run length of coding and I did the prime one, fair enough. So we're just going to rename the Python file real quick. Right, let's see if the run length encoding is any more interesting. A new file, sec b run length encoding.py. Now this is kind of GCSE level. I mean, already okay. That's the question. It's going to magically appear any moment now. Yeah, here we go. Yes. Okay, right, the program will perform the compression will display a suitable prompt asking the user to input the text to compress and output the compressed text. Text, not with capitals, text. Text is equal to, the text, some text, I guess. And then, okay, so, absolute bloody nightmare. Okay, they tell you it needs to look like this. So the compressed text seems to presume a sort of string with the space and so on. But we're going to need to work out for each how many consecutives of those numbers. So we're going to iterate for character in. No, we can't do it like this. For I in length, in range length text. So this is going to iterate from 0 to the length of the text, etc. And then we say current characters. Okay, output. Yeah, let's make this straight as a string. I'm feeling lucky. The current character. Okay, so if I reset my thing. So I'm just going to wait one minute just to check it. Okay. We're going mouse phantom, you don't have to have anything to worry about. We go through the text but with explicit iterators because we're going to need to move it along, right? Obviously. So the current characters, current char is text at I. Fair enough. Current count is 1 because we know that we have found it at least once at I, right? And then while. Okay, so if I just do E. Ooh, is that gonna? Can I just like? Yeah, I can. No, I can't. I can't even do it with. Yeah, no, I just. Okay, right. Yeah. Fair enough. So I'm going to have a manual, like not even an explicit iterator, a manual iterator. So my I starts at 0, and whilst I've not reached the end, right? So like while I is smaller or equal to the length of text. Okay, we're back on track. I just need not to forget to so I plus equal 1, we increment it, and whilst, this is like the British version of the while loop, while, what I'm finding, so I've already incremented it, so what I'm finding at this is equal to the current character. So it might happen once, might happen twice, and so on. I am going to current count incremented by 1, and then I incremented by 1, 2, and Okay, and once we've done this, we want to say that the output, which for some reason I've capitalized, which I don't like, so I'm going to uncapitalize it, which is a string. So a string, they're not mutable, you can't really append, so you create a new string that's made of itself, so it's a plus equal, right? Output equal output plus equal. And that's going to be the, I guess, the current, oh man. Yeah, well, I'll go for it. The current characters, the current character, current car plus a space plus the current count cast to a string. And so we add this to the output at the end of this one, but still within this one, right? And I guess that at the end we print the output. You could hear from the pitch how confident I am about this strategy, but we'll find out. You know, let's be brave. Okay, excellent. Well, we're already nailing this. Like, how is this even possible? Given that it should start. Oh yeah, no, sorry. Yeah. Okay. Da-da-da. Oh, there's some serious wind outside. Okay, some text, I guess. So let's say, no, shit, with one T and one exclamation mark. Okay, so we know it doesn't work, which is very helpful. So what's happened is we get the index out of range, because at this point, the last one in particular, right? You do this incrementation and you don't check. Okay, so if I mean this could happen, right? Okay, we can't have I. We need to have it in the we need to have it in the while. So we need to check in the while that we can get a text I, so that I is still smaller than the length of the text, and the text I, the next I is the current character. So because like at this stage, we might have incremented like past this, in which case we don't want to go this. We might, in that instance, we'll stick the current character here, and then output. That now should work. Okay, some text, I guess. Oh gosh. Okay, still not happening. Right, well, let's use a breakpoint and debug it then. Yes, with a Python debugger. I mean, what do you think I'm going to do to debug it? JavaScript? Current, what kind of dumb questions are those things? Okay. It's going to take 10 minutes to launch 14 lines of Python because it's like industrial grade debugger. All right. Boom. Okay. S is not defined. Oh yeah, there's much expressions from bygone era of testing. Could I have? Yeah, thank you. I equal 1. I'm happy with this. It does the thing. It does it once. 2, 3, 4. So A5, and there were 5 A's in it, so I'm pretty happy about this. Oh, I need some space after, so I should have also put, yeah, boom. Okay, so it's when it's kind of the very end, it messes up. I should have gone for something shorter. Oh, yeah, okay, sorry. If I, and I think we needed like maybe even. Okay, I'm going to try it again, but on a smaller string. Take forever. Yeah, Okay, current count 1, current count 2, and then A2 and a space, cool. And then the R1 and the G up. Here we go, index out of range. So we had I equal 4 on a string of 0, 1, 2, 3, and then no, it should be smaller. Yeah, because the last element, sorry, the last element is always, yeah, that's why we get this, right? No, the length of the text is always one more than the last element. Yeah, gosh, yeah, duh. Right, back on track. Just, let's try it now. GGH. Yeah, and if I do it again, but with some profanity, yeah, for this 4 use, 4 eyes, for these, for okay. So that's the run. To recap, there's some gotcha, right? But like the principle is you go through the string, like character by character, but because you're going to move the iterator along, you need full control over the iterator. You can't have a for loop, because the for loop, if you fiddle with I in the middle, at the next iteration, it just reads it. Remember, they're actually, the for loops in Python are always for each, right? They kind of read it from an element in the list. That's why we call range when we want a numerical iterator. So and then you make sure that this I should always be smaller than length, right? Because on the last, so you know, if we get 4 characters, the length is 4, the last index is 5. And in fact, so you want to do this, but like this is already invalid. So if I'm the last one, this is going to take it over the edge. So we check it. So when checking an end condition, if the first one is false, we don't even bother to check the next one, which is good because this would yield an out of bounds error. This is why this got fixed when I removed the equal here. Right, there was the RLE. It's not even an error. Okay, right. I think it's going to be a zigzag 15. Do you guys remember that one? That like encoding the whole thing in a okay. So like the ZigZag 15 is to save and load the game basically based on a set of strings. So the autosolver we've done. Duplicate one. Now, this is the code for this is kind of a sensible section D task. The problem with that stuff is you can't, it's difficult to test, right? Because to test, you have to kind of like, you know, test again until you see that you've not got a duplicate number. But we can do, no, it's 15, it was after 15, right? Okay, here we go. Yes. Oh my God, this is gonna be boss hog. I'm so excited. All right, let's paste it. And the Z15.py. Someone wanted like screenshots for this, saying, oh, it's going to be very helpful from the revision. It's like, did your teacher ask to do it and you want the screenshots, so I do it for you? All right, ZigZag 15, we can close all of the rest. We probably don't even need this until we debug. Okay, your mission, if you're willing to accept it. Standard random game must target thing. So we've got the ASCII table. You know that it's CHR and ORD to get to, you know, go from character to this. I'm surprised there's some that are going to be like breaking everything because some are kind of special. But are we doing restore before we do save? Okay. Opening menu, load the previous game using encoding string. Okay, main playing numbers allowed. Load from previous state encoding string. Oh, U type, like the user type is the encoding string. Okay. A suitable error. What? Ah, okay. So it's nothing to do with a file. Yeah, no, okay. I can dig this. And play game. Let's do, okay, let's start with play game. So we play game, we're in safe end. So what we want, it's not even play game, actually, it's surely it's not even play game, it's main, yeah. And play game method, well, play game. Oh, you probably don't touch play game. All right. L to load. Oh, this one does it to lower. That's interesting. S to load a game state. Oh no, I can't do that because it's an input, right? Yeah. Fine, it's gonna be a big one, right? If the choice is this else, we get an L. Else, this is not a Y, right? But we've got max number. That's true. But before we do those two things, oh, shoot. Okay, so it's gonna be before we. Yeah, okay. Now we want this to be, because this affects regenerating some further numbers, well, it doesn't really matter, but they want it to be that game. So in here, okay, yeah, I think in here I'm just putting I want to separate one to say if, because we'll redo the targets and numbers allowed, but if that was equal to load, they put it in lower, right? So we want, or big L is going to be something. Going to become a small L, and then in here we're going to want to I'm going to put pass. So yeah, pass, but this needs to, like, this will set. So if we switch as choice L, sets numbers allowed and targets. So that's what it does in here, which is why I need to move the numbers allowed, the kind of regular loading of the numbers allowed, into an else branch, and then we kind of play game with those things, right? So it's set numbers allowed and target based on this new restore game. And it's encoded by first 20 are the targets with at being -1, next 5, and the final is the score. Okay. Ooh. So it has to be 26 characters. Is that how we validate it? Incorrect length contains invalid characters. Yeah, because we expect that would make. Does it make sense? So we only go to 50, which should be in here. So if you see any character above this, right, that the dot, no, the dot was below. Oh. Sorry, I really badly need the loo. This is making me jittery and I can't focus on this. I will take, like, give me 5. Okay, I've got my classic teacher thing. 5 minutes. Sorry, the mic's not here. 5 minute timer. Sorry, I'm bursting. Ta-da! Excellent. Oh, whatever, it doesn't really matter where it's stuck or where it points, it's omnidirectional. Wow, okay, yeah. Back on track, with my apologies. Yes, okay, so we want restore game that will then, but this restore game, so I think this is where we need to change the play game, because play game does not take the score, it sets the score here. So instead, I'm gonna let play game accept the score, and in this score equals 0, it's going to go into this one. So again, the default, and this one. And then we're going to call play game with the score, because this is where we are going to get the I guess the targets, numbers allowed, and the score from this new function that's going to do absolutely everything, which is going to be fantastic. Once it's except we need to write it. Restore game, and it just like this, it takes nothing, right? It's just yeah, it is what it is. Fine. Well, might as well put it in here. Okay, so game string. Game state string. Okay, enter the game state string, and then we need to check. So just no, can we? Not at all what I wanted to do. Right. Okay, subtract 64 from the ASCII equivalent of each character in the game, the number D to the 4, because D, capital D, is 68, you subtract 64, and you get the number. So that means that we are not considering, so any character before, yeah, any character before 64 is, or maybe even 65, is even non-valid, right? Well, no, because we get at, where was at? It's 64, yeah, that's why it's 64, okay, right. So this is how we know it is valid. This is how we check the validity, right? So incorrect length for invalid characters. So if, you know, let's do it the old school way, valid equal false. Wow, not valid. If game string so this should really be exactly 26 characters, right? Yeah. It's not exactly 26 characters. We continue. And then if, so let me see how I could, S equal A, B, C, D. Okay. And if I do old, yes, cool. And then I could use map Oh, this is vicious, right? So that's checking the length, and then let's say that the characters are made of the, well, the no, actually these are numbers, right? The values are the list of the ASCII number of the character for the character in game string. You know, I might even kind of like I might even subtract 64 here. And okay, so this is where we want to test that if any of those values okay, for so we go over the values, and if we find something that's smaller than 0, we continue because it's not the right one, right? Which means that if we're here, which means we set to set valid to true and exit that. Now I should be able, like I did last time, to be able to import. I might need to actually kill Python because it's got the thing cached. From Z15 import, no, big Z. I don't know if it matters, but import restore game. Okay, so this is not valid, and then the one we give to test should hopefully, oh. Yeah, that's a valid one. It kind of like dropped the bottom. Okay, so I've accepted the string and validated it, and if I'm here, I've got this, and also I've got values, and values is going to be helpful. It's quite interesting because this is actually we shouldn't have any zeros in this game. So like here we're going to get a -1. That's like kind of 0. Anyway, we need to build. So subset of values though, because that's like 0 up until, okay, correct list 1, 2, 3, 4, 5, 7, for instance. L up until 4. Yeah, so I want, so the first 20 are, this is getting tiny now, but first 20 characters, right? So we can say that like the targets would be the first 20. But this should work. Ooh, okay, I'm feeling confident. I thought we could put an else in there, but no, that's gonna select. That's the problem. So I can't. Okay. Targets is the first 20 values. subtract 64. 4. Right, so at is going to come to 0. If there was a substituted, right, so the value is up to 20, and then I need to kind of like replace zeros by -1, which I think there's a Pythonic way to do it. The numbers allowed equal values so from the one at index 20, which is the 21st, to to 25, I guess, yeah, right, because it's like 5 numbers allowed, and then score okay, now replacing zeros by -1s. Okay, like this is harder than it looks. There are list component. There should be a okay. Line. Wait, are we going to need to do it old school for line range of length of targets? No, not like that. So we iterate over it with an explicit iterator, and if what we found at targets at an index I happens to be a 0, it needs to become equal to a -1. It becomes equal to -1. The numbers allowed, we just get strength from the next 5 numbers, and the last one is the score, and then finally what we have to do is return targets. Numbers allowed. Is that the old order in which I did that? Targets numbers allowed score, because that's the way it's written in the string. I mean, I'm not usually confident, but when am I ever? Okay, there's no immediate wiggles that are going to waste me sometimes if I run it. So, yeah, no, it sounds still good. Right. L. Oh, there needs to be a suitable error. So, okay, fine. We kind of like need to do something here. Yes, this is obviously for A level. The computer, so yeah, computer science GCSE finished last Tuesday. I invigilated the edXL on computer one. They have an on computer. Fun times. String contains illegal characters, I guess, or yeah. It is AQA, yes. Nifujan. Okay, try again. Load game.txt. I think it's too short, and then we enter this beauty. I mean, kind of did half the job, I guess, right? Not, yeah. Okay, so let's find out what's wrong here. But I'm not too. It's a fun one because it's, if it had broken with an ugly error, it would have been ugly. This is kind of something that's very interesting to debug. So I put the targets in there. I mean, I think at this stage the main thing would be to do this and debug it. I've not even seen 2024 paper, so I don't know how simple puzzle, and I don't know whether they're done on section B. Then run and debug, come on. Load. And then let's put that big old game string here. Poof. Okay, what have we got? That's the value 0, 0, 0, 0 values. Oh, no, that was, I'm fine. Targets, and so, no, don't need, the values are kind of as expected. Targets is -1, -1, -1. So, ooh. Yeah, that's an issue there. So maybe the values are messed up. No, they should be 17, 38, and so on. What's going on with my... Oh, yeah, that's not, yeah. That's more like what you need to do, because this is we're setting all of them to -1. That's the problem. Cool. So I don't even, now that was the bug. I've debugged it. We're good. We're back on track. I'm loading, and so any old filling will not work most of the time. And boom. Okay. Yeah. That's 15. Now we could, is this a good one? Is this even like a good game? Time 9, 7, I can probably do something 36, 38, 39, 36, 9 times 4, or 9 times 4, 46. 9, 7 is 60, 63, 9 times 8 is 72. 27 minus 27 plus, god damn, it's a nightmare. I mean, I can do 3 times 1, 26 of those. 8 times 5. I need to take care of that 38 because it's coming soon. 9 times 4, 36 plus 1. No, god damn it. 9 times 8. 9 times, no, 7 plus. Okay, fine. 11, 14. Can I just sum them? Will it be as simple as that? I get like, this is like 16, 20, 30, 31. Well, I can do 31 and get fresh numbers. Oh yeah, sorry, that's a very good point. I didn't show the diff on. I was like getting lost in this excellent game. So I still have the, let me just move this over here. We don't need that guy anymore. And I still have the original selected as the point of comparison, and my Z15 freshly done is... So couple of changes to main, right? Mainly we kind of, this is where we branch off and have the possibility of this. I need to move all of the score initialization out of play game and inside main, because the score is one of the things we can recover from the, from the get restore game. And what else changes it? So like the score needs to be initialized here, and then this is the new choice. So we will do this, in particular we will set those values, that's important. But this will wipe immediately after. If the choices there are, I've not done, I think the path should have been removed here. I don't know. So if the choices were, we just get the state of the game, which is targets, numbers allowed, and score from restore game. Otherwise, we get numbers allowed from a regular fill number, and we set the score to 0. I could like nest this and make that. If you want this to cleaner, to be honest, I would kind of like move this. It's here. And actually nest this inside this. It still runs, right? And the main, so we change play game we pass the score to play game, and so lower down we also need to accept the score and play game. But like the bulk of what we've done is this new restore game function. There's a bit of input validation. We're checking length, and we're checking that none of the, once you convert them to the values in subtract 64, everything should be at least 0. So this is another case that you can think. If we're here, the strings are valid, and we have values, by the way, right? Those are the actual numbers we're after. So target is the first numbers, although for those, if we find a 0, that was the at symbol, then it's a blank space, it needs to be a -1. Numbers allowed straight up is the next 5 numbers in the list, and score is the last one. We return those as a tuple, right? You can return more than one argument, right? And then that's being read here, targets, numbers allowed, and score, and then we go into play game with targets, numbers allowed, and score. And that's the diff, mouse, phantom. Okay, should we do, I mean, I don't know, kind of like, I've budgeted until 12, and I can see I've got 3 concurrent viewers, so it's exciting. Let's see if there's something more. I'm not doing the brackets before you ask, just, I'm not even touching this. Yeah, to duplicate, have we done this? No, this is kind of like the error messages. I think there's a bit of oh, this one at least kind of highlight. This is more about highlighting. We did the freezing the target. That's a pretty good one. I can invent a task. I was thinking it's pretty cool. You can just say pack, and then if you get holes, you just like pack them all at the back of the list to give a thing, but maybe at the cost of 5 points or something. But the pairs of target, I like this. Let's do task 13. Z13, okay, and this time we want to be doing, save this, close it, also close the original, yes I want to, yeah. I'm literally giving instruction faster than Visual Studio Code could. This is an old computer. I need to get myself a new computer. Right, pairs of targets. So check the relation to all targets I get list. If there was just update targets to collapsing the gap formed, so it moves them. I mean, okay, so this matches the like 513, right, which there was a bunch. And what is this? I need to play the training game to see what's going on. So that's the state of it, right? And they're matching the 64. Are they? No, 68. There's 2 68s. Is there? There isn't. And 22 into 130. What? Oh, divided by 2 plus 2. So it's 32. Oh, I see. Okay. Huh. Yes, okay. It's 30. So it's 32 plus 2 is 34 they're matching. And there's 2 34s here and here. But it does, yeah, what they mean collapse is that the 23, 19, 43 just kind of gets straight after, and like the whole back is populated, backfilling, right? So this is kind of, yeah, it's not just we clear in all the middle. From the 19th, I think I mentioned them as I go along, but like definitely the quitting the game, and so that's the first one. The accepting powers, exponentiation, that would be a good one. The other, you may have something like that, but you cannot have anything that cannot be tested in like clearly, unambiguously with a simple set of test plans. So you cannot have anything that involves refactoring the code without changing visible functionality, and you cannot have anything that revolves on like, oh, make sure there's no duplicates in the thing, because because it's based on randomness. You need more than one kind of attempt to do that. I think when I do individual videos, I try to conclude even in the comments, like to see how like legit and realistic that is, but you know, it's not. Ultimately, those are meant to train you on the code base so that you can tackle any task rather than train you towards specific tasks. But there's some kind of low-hanging fruit that are going to be, yeah, I think the exponents might show up, maybe quit the game as well. So no, it's not Halbman, we're doing the other one, we're doing for 13. Okay, I think I understand what they want from us, and I can also see why there's nothing that is, yeah, check it. So this one will, right? This is when it wipes it. So, ooh, this is bad. Oh no, okay. Well, so that means we need to kind of like get targets back in return. Well, fine. Okay, so we're gonna need to maybe get targets again back from here, which it. To be fair, we don't need to get targets because it changes straight in the thing, right? So this change when we wipe the captured one, we wipe the clear one, set it to -1. This actually affects the list. We don't have to return it, right? Because lists are by reference, so it affects the value directly in memory. So in here, I need. Okay. Okay. If first, if not first, so if we don't have anything, then first becomes equal to count. Count. Right, so that's like for the first target. Else, so we want to collapse a whole list, which means I think we can like, yeah, let's simulate this. Oh, something was running. Okay, let's simulate this in Python. We want quite a long list. Okay, that's L. So let's say I matched, I would say the 8 and the 16, right? Or I'm going to get first equal 8. And then my count, I found the second one at 16, right? Count the 16. So if I want to wipe, if I want to basically clear anything in the middle, I can say, I can make a list that's like everything up to and not including first, because we've captured it, right? And then on this, I'm going to stack everything that's after count. So, but not including count, so even count +1. Which, if it's the last one, we're gonna have some issues, but you know, let's not worry about this just now. To the end. No, that's actually count +1 to the end will give us the empty list. So now we've got, yeah, 7, 17, 18, 19. This is what they want. And then they'll just have to make it up to. I mean, whatever happens, because we're keeping the targets in the. I think like evaluate, refill targets or whatever, update targets, yeah, we will need to change, but this does the job, right? This, if we get the address, if we get the index of the first, this Nepali man, and Nepali man, you were asking about the Dijkstra, I think, last week. I've done it in the first hour. I did it in the first 20 minutes, it was kind of amazing. Yeah, right. So if we want to effectively delete anything between the two targets, it's like take the list up to, but not including the first one, and then from the one after the second one to the end. And then we're just gonna, else, it's literally, it's ugly, but targets becomes equal to targets up until first plus targets from count +1. I don't know why I've always put an R. It's not even, it's kind of close to it. To the end. And that's kind of half the battle, because we don't change anything we return. The undo oop, but like you don't need oop to do the undo, right? Like they can do, but you're right that this is one that uses the new data structure that you could do in oop. Except the way they've done it, it's not particularly clear whether the object is meant to represent one game state that you put onto a stack that may not be oop, or like if the class you're doing is kind of maintaining its own stack inside. But you could have oop undo. The oop undo would be really fiddly, but I think the yeah, can we? This was when's the undo? We've done the undo, haven't we? Object orientation to the previous move. Yeah. So undo state. Okay, so this is like an undo state object, and add to undo. So that's the problem. If it's an undo state, add to undo effectively touches something. It's really bad encapsulation the way it's been defined here, right? Because like clearly the objects are created, the class are created as undo state. Add to undo. Oh, so that's the new function. They're just calling everything. They're just calling everything method because they're fucking idiots. But like they don't mean a method to the new object, do they? Right? Because they use the phrase method everywhere anyway, right? Like when they talk about the functions in the game. So again, yeah, if you correct for the zigzag, looseness, which is the tightest we can get, to be fair, the oop one might not be a. There's not. Yeah, you're right. It's not a difficult one to do as long as it clearly stated. Because yeah, that certainly threw me. But I guess I can believe you guys would be better than me. All right, so update targets. What does that do? It updates the targets, you might say, but. This doesn't change anything. Yeah, but like that. But to be fair, that's true of a lot of oop. But like you presumably use oop in your projects. I mean, like I guess that because it's such a big news to the A-level students, like it's a new part of the material, right? I was seeing this, by the way, only in postgrad cycle, and it took me, I didn't get it the first semester on C++, and it was really when I did Java the next semester that I twigged, and you guys expected to do it in like half a term. But oop, I can see why it would be puzzling, but remember there's also plenty of stuff that you only see at A-level, like, Dijkstra, and like the fact that there isn't any Dijkstra on one exam wouldn't shock everyone. You don't expect it to be there all the time. So, they need to cover the whole spec across 5 years. So really they could afford to only put oop onto one exam every 5 years. Anyway, so the problem, the new issue here is that targets may count in ways. So this is the one that shifts them and pops them and so on. So you want 14, right? 13, I'm back on track. And any of the methods required to create a list of a number of targets. Okay, I'm gonna do that because at the moment, so it pops the first one, which hopefully is going to be -1, otherwise you've lost, and then it tags stuff at the end after it's kind of shifted everything, right? So here we want to do that, but it only does once because it's assumed you just need to kind of move by once. Here I'm going to want to do that whilst. Ooh, can I literally just like name targets is. I feel really. I'm really unconvinced about this, but we'll find out, right? Ooh, hello. Yes, obviously you expected I can see why that would be the case. And also we want this indented, right? So we're going to repeat that. Instead of doing it once, we're going to do it as many times as we need to fill in the back of the target list. I'm gonna play a random game to kind of have a bit more fun with the filling. What have I got duplicates? Yes, 42. No, yes, 42. 7 minus 1. Right, 7 minus 1 times 7. Boom. So, okay, what's happened? No, it's not done it. Oh, because it does, sorry, it doesn't do bracket. Yeah, sorry. And, So this has done 7 minus 7. Yeah, not helpful. 42. So I can't. Yeah, the precedence applies. Okay, maybe I need to do a training game after all. Why do you say Mouse Phantom? Why do you say paper 2? It's easier to check what will come, because you don't get any AD for paper 2. You think you're doing it by like what came out last year and the year before and so on. Training game. Okay, and we need to match the. Okay, 32. 5 will divide 8. Divide 2 plus 2. So okay, we want to watch out for here. Oh. Yeah, that's a problem we have in check if the evaluation is a target. Okay, so let's run it. So no breakpoint, but it will breakpoint on uncode and raised exceptions, actually, all raised exceptions. Okay, debug PyLonger. Yeah, that's possible. I mean, we can have a look at like that. I think I did a video about the mark schemes and like the stressing in particular that like it's worth attempting the problems because it's always worth getting the entry level marks. 5, 12 divide 8 divide 2 plus 2. Okay, that's the problem here, because count is 15, because we've don't have 15 anymore in the targets. Yes, right, it seems to have crashed, removed a whole bunch of stuff, which is what we wanted. So 34 is after the 121, right? So 20, 34, 121, and then boom, it goes all the way to the 23. So we've collapsed it. Oh, then we need to bail. That's what they mean by not to consider scenario moment and to duplicate. So we're not even gonna. No, we're not gonna bail. I'm just gonna say like new target. So I could either I could exit. I could kind of like break out of this to say, right, we've cleared 2 targets and everything in the middle, we're fine. But that mean we won't clear the third one if there's a third one in there. They say not to consider the scenario. Yeah, we could have left it and not cleared it at all. This one will clear it. It'll just set the new targets, and then at the end, but before returning, if new target, so if we have they're not none, then we set targets to new target. Okay, save it and run it. They can have something bad. I would worry more about like, look, in this thing, right? There's like types of mathematical expression. You get your RPN, your infix, your postfix, RPN the same. So that's one, right? Converting between them. So accepting things in prefix could very well be one. You also have regular expressions, and you're meant to know about regular expression. It's on the spec, and that's one that's kind of often under-evaluated. And I would, know at least, I mean, you figure them out, right? Like the very first one we did for the exponent, you know where the regex are. If you want to add something, like accept spaces in the expression would perhaps be a good one. Anyway, the random game, and 5, 12, 8, 2, but then plus 2. Am I not checking the same? Am I not playing the same game anymore? This is meant to be, what was it? What did they run? 13, right? If new targets, I guess it's a new target. And then that did not do that at all. Let's try this again. Yay, okay, 5, 12, divide 8 is 64, divide 2 more, it's 32, and plus 2 to get me to 34. It's not even, guys, not even, what? Are we? Okay, I'm gonna put one here and then put one there and then run in debug. Oh, maybe I hadn't, to be fair, I wasn't running it in debug mode, I think, maybe? Yeah, we all do Python, right, Napoleon? Yeah, the rest, I don't know, because they're not using, you know, they could use the, that's the thing, like their regular expressions are not like implementation specific, because you get things like \d for a digit, which sells you a lot of 0, 9 plus type affairs. Okay, again, 512 divide 8 divide 2 plus 2. Right, so first is none. So if not first, we count it, we're happy. And now we've got, yeah, first was then, count was 14. Right, so this is gonna set the new targets to new targets. And then surely set targets to new targets, yes. And those, so now it's only 15 long or 20, no. Oh, it's about to do it, right? It sets target to new target and then doesn't display the right thing. It's just, what? I don't understand what's going on here. Task 16? Am I done task 16? Is that the first helper? Oh yeah, in brackets. Yeah, no, I'm not like, fuck that. I'm not touching this. I've tried so many times, and I kind of, because I made videos about the thing, and it came out at like an hour and a half. But to be fair, there's like 30 minutes just to redo the validation. No, I've not done brackets. I've done like the theory that leads to bracket, because I wanted to do the brackets, and my shame, this has become my nemesis, the bracket tasks. Yeah, maybe next week, but like, no, in 20 minutes. But like, I owe you the brackets. I appreciate that. I will also tell you the brackets are far too complicated to actually end up on the exam on the day. Right, let's try and do this again. Boom, okay. New targets is 15 long, and targets is 20 long, right? Which means that if I come out of, you know, here, say, then targets, oh, it's not really displayed there, but like targets, I don't know why like targets have been, okay, maybe no, because we're not updated the targets yet. I don't like this at all. Okay, so if I put the breakpoint like here, so after I've assigned one to the other, yeah, it is long to do the bracket task, and it is longer if you don't do if you do it to do it. It is longer if you don't do it right the first time. And the way it's essentially actually a finite state machine, right? Because you're ever reading a number that any number of numbers, and then that's the end. It defeats some assumptions in that instead of expecting a number, you might expect a bracket. Instead of expecting an operator, you might expect a closing bracket. So this little, it's interesting, meaning it's too complicated for a legit question, but it's worth doing. I'll do it for the next one. Yeah, it is what it is. Right, so when I come out of this, targets is 15, right? That's targets. But when I kind of next hit that, targets has become just what it was. I don't get it. Yeah, the other option was Because the problem is that if that doesn't work as I expected, we might have a broader problem even if I break. So if we break here, we won't have the issue of like we've kind of made a smaller target list and then we expect it to iterate and continue iterating of it. Which means if there's a third one further down the target carousel, we'll not clear it. We have to deal with that. We have to live with that. It's all Gucci. Okay. Okay, so let me just want to see that. How long is this? This is the short target list. Very happy with that. And suddenly this is the long target list. It's kind of, yeah. Okay, so this is annoying. Oh, maybe I need to make it global. You know, I guess we're just gonna, you know what, I'm gonna, fine. Let's just say passes targets back up, right? That's fine. So in this one, is target score, we get targets back out, meaning that I'm going to be watching for this guy. Yes, Nepali man, yeah, please attempt all of the tasks. You get like 2 free marks just for like, you know, if they ask you for a new function, you create the thing, you give it the right name, maybe you get a loop in there, or maybe you read an input correctly and then you're halfway. Well, you can have 3 out of 14 marks there, but it's still better than getting none at all. 5, 12, divide 8, divide 2 plus 2. Okay, we're kind of happy here. We're going to go into update targets with a short target list. Oh no. Huh. Did I mess this up? I feel I've not captured anything. Is that what? What's happening? Okay, yeah, no, we do that, and now we have the short, no, the new one, yes. Well, no. 38, wow, are those still 38 in the thing? Did I mess this up? Yeah, I messed this up, didn't I? Okay. Oh, because I'm not playing the training game. Jesus Christ. Okay, I think this is nearly the end. I'm running out. Clearly, I'm running out of steam. Okay, run and debug. Get both of them. Yeah, whatever. Okay. Okay, the training game. 5, 12, divide 8, divide 2 plus 2. This is now the shorter target list because we're clear in the middle, and we update the targets. Let's go into update targets, and before we turn targets, put a breakpoint here. And now, right, it has 23, 9, 140, 82, 121, and then boom. And then the 23, 119, 24 that we had before, and then all of the 119s at the back of it. And it's now a full, 20 long. So that while that kind of, fill up the back until you've done is helpful. The fact that it doesn't is 5. Okay, what's the 256, 127, 127 minus 8, right? So it's like then if I do 512 divide 2, 256 divide 2, and then minus 8, I'm clearing all of the, no? Well, yeah, okay, fine. I don't want to, yeah, no. I should clear all of the 119. And I didn't. Huh. Fancy that. 512 divided by 2 is 256, divided by 2 again is 128. I can't, it's not the right number. Still, okay, it kind of works. I'm happy that this meets the brief. I wish I could, yeah, there's better ways to do this. So we find out that, you know, like if you change stuff within, if it doesn't have the global scope, if you change stuff within the function, it does only change it, thankfully, within the function, which we need to pass it. Because I keep on banging on about this, and I think I got tripped up by something fairly basic that I'm slightly embarrassed by, but I don't think anyone's noticed. Well, Godwin Dominic, I guess that's the right attitude, but, you know, you can scrape more than, you know, it's not just scraping. You can, like, certainly the section B, I think if you like coding, if you kind of hack this, but yeah, of course it's all about the numbers. Anyway, all right, so what I've changed here for this one, we need to change the return signature of check user evaluation to the target because it's going to mess with the targets list, so we need to return the targets list. What we do is we don't use this after all. What we do is we store the number of the first time we've encountered something. So this is when we match and clear it. And so this is where we would say, if it's not the first one, we set it to the count, which means the second time we encounter the number. So if there is a first, we redefine the target list as being everything up, but excluding kind of the first one we matched, and then the back of the list after the second one, clung them together, then return this. This comes back up into play game. And so when we call update targets here, update targets, all I've done is the place that appends something at the back that normally would expect to only append one because we've just popped one on the front. I'm going to do it whilst the length of target is not 20, because we should have 20, you know, make it up to 20 targets total. And that's your Z13. So I'm just reading the chat. It's to be, yeah, I mean, not the most exciting thing to be doing the summer of your 18-year-old, but right. Wasn't there an education secretary that said, oh, in 10 years' time, no one will care about your A-level marks? And indeed, I think even in 10 months' time, no one will particularly care, not least of which, or first among whomst yourself. Right, thanks for watching. Sorry, I should have kind of a scheduled that, but now they are announced and scheduled for the next two. It's only two left Tuesdays, so there's going to be the first 11 days to go, and then the 8th with 3 days to go. I will see you again, much like some kind of a Sunday morning religious ritual where we go and worship the machine god. No, let's stop there. See you soon. Best of luck for your Asian. Go and do another subject for a change. This, and maybe touch grass as well. I mean, it's nice where I am. Get some fresh air. Don't overdo it on the